Welcome to my channel. Today we are going to solve the frequency sampling method problem from the FIR filter design. Okay, already we solved the two problem from using this frequency sampling method. Okay, so now we are going to solve one more problem with a specification is given differently. Okay, so in previous question the specification given us in first problem, the HD of e power j omega, it will be given. Then in second problem, h of 2 pi k by n value, it will be given. But here, the cutoff frequency and sampling frequency is given. We have to design the corresponding filter. Okay. So you see the question, using frequency sampling method, design a band pass filter. Okay, with the following specification. Sampling frequency is 8000 hertz, that is 8 kilohertz. Cutoff frequency FC1 is 1000 hertz and FC2 is 3000 hertz. Okay. So determine the filter coefficient for capital N equal to 7. So here the cutoff frequency in hertz it will be given, but we want the cutoff frequency in radians. Okay. So that's why first we have to convert this lower cutoff frequency FC1 and FC2 into the corresponding radian cutoff frequency. Okay, digital frequency we have to convert it. So what is the formula in order to convert this frequency in hertz to radian frequency means, so the omega c1, so you see the omega c1, the cutoff frequency omega c equal to 2 pi f into t. Okay, so if you want to convert into digital, we have to multiply with the sampling time. Okay, so here the sampling frequency is given. So you know the relation between sampling time and sampling frequency, the reciprocal of the sampling frequency, it is called as a sampling time. Okay, so that's why the omega c1 can be written as 2 pi fc1 divided by f. Okay, this t is nothing but 1 divided by f. Okay, so in this formula you just substitute the fc1 value and the f value. So 2 pi into, what is fc1? The lower cutoff frequency is 1000 hertz divided by the sampling frequency is 8000. So 2 pi 1000 divided by 8000, so which is equal to pi by 4. Okay, so pi by 4 radians. Similarly, the upper cutoff frequency omega c2 is calculated by 2 pi fc2 into t. So 2 pi fc2 is 3000 divided by 8000. So we may get 3 pi by 4. So here, what is the filter they are giving? Band pass filter. So this band pass filter, it will allow the frequency from, so you just consider this is omega equal to 0. This is pi by 4 and this is 3 pi by 4 means, so band pass filter means, you know, band pass filter means it allows the frequency in between this two cutoff frequency. So in between pi by 4 to 3 pi by 4, that HD of e power j omega, it is 1. Okay, so for the remaining frequency 0 to pi by 4, it will not allow. 3 pi by 4 to pi, it will not allow. Okay, so that is a stop band. This is called as a pass band. Okay, so this filter we are going to design using which method? Frequency sampling method. Okay, and here one more data is given that we have to determine the filter coefficient for capital N equal to 7. Okay, 7 samples we are going to solve. Okay, so after calculating the cutoff frequency, so you just draw the frequency response. Okay, so you see this is the this dotted line indicates. Okay, so you see this dotted line indicates the HD of e power j omega. This solid line indicates h of k. Okay, so already you know the procedure in order to solve the frequency sampling method. So in frequency sampling, not to solve the frequency sampling method, first we have to determine the modulus of h of k and the angle of h of k. So how can you calculate the modulus of h of k means, the h of k is nothing but we have to sample the HD of e power j omega for the value omega equal to 2 pi k by n. Okay, so here n is 7, so 7. For the k between 0 to n minus 1. So 0 to n minus 1 means 7 minus 1, 6. So in this interval, we have to sample our frequency response. So that value we are calling it as a h of k. Okay. So this h of k we have to find out. So in order to find out this h of k, so first we have to determine the omega k value. So what is omega k? The omega k is nothing but 2 pi k by 7 for k is from 0 to n minus 1. So first for k equal to 0. Okay, so for k equal to 0, if you are substituting k is 0 means we can get the omega 0 equal to 0. Similarly for k equal to 1, so 2 pi 1 divided by 7, so 2 pi by 7. So if instead of this pi, if you are, that is in degree, the pi is nothing but 180 degree. If you are substituting, we may get the angle 51.43 degree. Okay. Or otherwise, if you are considering pi as 3.14 means we may get different answer. Here I am taking the angle that is this pi I am taking as a 180 degree. So 2 into 180 divided by 7, we may get 51.43 degrees. Similarly, for k equal to 2, 102.85 degree. For k equal to 3, 154. K equal to 4, this. K equal to 5, this. K equal to 6, this. Okay. So for this 7k value, we are going to take a sampling. Okay. This hd of e power j omega, we are going to make the sample. This dotted line indicates the frequency response of our band pass filter. So you see, this band pass filter, it will allow the frequency from pi by 4 to 3 pi by 4. And this 3 pi by 4 to pi, it will not allow, it is said to be the stop band. Okay, this is stop band, this is said to be the pass band. And again, you know, all FAR filters are symmetric. Okay, symmetric and as well as periodicity. After this pi, again and again the response is repeating in the same shape. Okay, so that's why after this pi, again pi to 5 pi by 4, it is a stop band. 5 pi by 4 to 7 pi by 4, it is a pass band. Okay, so after that up to 2 pi, it's a stop band. Okay, this is the thing. So now we have to sample this hd of e power j omega for k equal to 0, 1, 2, 3, etc. Okay, so you see, if k equal to 0 means what is the angle omega? Omega is 0. So where is the, this is omega pi by 4. So this is omega is 0. So whenever k equal to 0, omega is 0. Okay, so at the time, what is the value of hd of e power j omega? 0. Okay, then for k equal to 1. So you see, for k equal to 1, what is the omega value? 51.43 degree. So 51, this pi by 4 is nothing but 45 degree. So 51 where it will come here. Okay, so this is, so at k equal to 1. So at k equal to 1, the omega value is 51. So under that omega equal to 51, what is the h of e power j omega value? It will be 1. So under k equal to 1, the h of k value is 1. Okay. Similarly, for k equal to 2, what is the omega value? 102.85. Okay. So where is the 102? This is 45. This 3 pi by 4 is 135. So 102 is, it may come here. Okay, so under k equal to 2. Okay, so k equal to 2. What is the hd of e power j omega? It becomes 1. Okay, so this is the second sample. So whenever k equal to 2, the modulus of h of k is 1. Okay, then for k equal to 3, what is the angle? 154. So this 154 is in the stop band. Okay, so k equal to 3, 154 degree. So it will come here. Similarly, for k equal to 4, 205, it is also available in stop band. For k equal to 5, 257. So the 257 is appearing in pass band. For k equal to 6, it is also available in pass band. So for k equal to 3 and 4, the modulus of h of k value is 0, 0. And for again for k equal to 5, k equal to 6, that hd of e power j omega, it takes the value 1. So modulus of h of k is equal to 1. Okay. So from that, so we have to take the 7 samples. So we taken the 7 sample for k equal to 0 to k equal to 6. Okay. So from that, from the figure, we can write it as the modulus of h of k equal to, so wherever this modulus of h of k, it becomes 1 for k equal to 1, k equal to 2, k equal to 5, k equal to 6. Okay. Then for k is 0, 3, 4, it will become 0. So this is the modulus of h of k. Okay, so using for a k, for different k value, you just find the omega. That omega value you just see that will available in pass band or stop band. It is under pass band means the modulus of h of k is 1. It is available in stop band means the h of modulus of h of k, it will be 0. Okay, so the modulus of h of k is calculated. Okay, this is the first step. Then after calculating modulus of h of k, the next step is to we have to find the theta of k. Okay, so the theta of k is equal to minus of you know the formula, if n is odd, if n is odd, the theta of k is equal to minus of n minus 1 by n pi k for the k is from 0, 1 up to n minus 1 by 2. Okay. Then for k is from n plus 1 by 2 to n minus 1, the formula is n minus 1 pi minus n minus 1 by n pi k. So you just remember this formula in order to find the angle theta of k. Okay. So in order to solve this problem, you just remember this formula. So in this, you just substitute capital N value. Okay. So if you are substituting, so for n equal to 7, so the theta of k is equal to minus of n minus 1. So 7 minus 1, 6. So minus 6 by 7 pi k. For the k is from 0 to n minus 1 by 2. So n minus 1 by 2, 7 minus 1 by 2 means 3. So for k is from 0 to 3, the theta of k equal to minus 6 by 7 pi k. Similarly, for k is from the remaining value, that is 4, 5, 6. What about the formula means? The n minus 1 pi minus of n minus 1 by n pi k. So the answer is 6 pi by 7 into 7 minus k. Okay, so we determined this theta of k formula also. Okay, then we have to combine the modulus of h of k and theta of k. Okay, theta of k value here in order to obtain the total response h of k. Okay, so the total value, the total DFT value h of k is obtained by modulus of h of k into e power j theta of k. Okay, so now we have to combine for the 7 samples. Okay, so you see first for k equal to, so you just combine this modulus of h of k and the theta of k. So here you see the modulus of h of k is 1 for the k value 1 to 5, 6. Okay, first for k equal to 0, what is the value? 0. So that's why, so you see for k equal to 0, the h of k becomes 0. Since the modulus of h of k is 0, so 0 into e power anything 0. Okay, then for k equal to 1 and 2. So for k is 1 and 2, what is the modulus of h of k? 1. And for k equal to 1 and 2, what about the angle? The angle is minus 6 by 7 pi k. So we can write it as the modulus of h of k 1 into e power minus j theta. Okay, so e power j theta. So the theta value is minus 6 pi k by 7. Okay, then for k equal to 3 and 4. So for k equal to 3, angle is there. But here the modulus of h of k value is 0 for 3 and 4. So that's why for 3 and 4, the h of k value becomes 0. Okay. Similarly for k equal to 5 and 6. So you see for k equal to 5 and 6, what is the modulus of h of k? 1. Similarly, you see here for 5 and 6, what is the angle? The angle is 6 pi by 7 into 7 minus k. So we can write it as, so for k equal to 5 comma 6, so the value is 1 into e power, the angle e power minus 6 pi by 7, 7 minus k. Okay, or e power minus j 6 pi k minus 7 divided by 7. So the h of k is calculated. Okay. So after calculating h of k, the next step is to we have to find the filter coefficient using the formula. So for the filter coefficient is calculated using in the frequency sampling method is calculated by the h of n is equal to 1 divided by n h of 0 plus 2 into summation k equal to 1 to n minus 1 by 2 real part of h of k into e power j 2 pi k n by 7. for n is from 0, 1 up to n minus 1. Okay, so here we have to substitute the n value. What is capital N? Capital N is 7. So 7 minus 1 by 2, 3. Okay, then we have to substitute the h of 0 and we have to expand this summation and so on. Okay, so you just see here, if you are expanding this summation, here we can get a h of 1, h of 2, h of 3. So you see h of 0 value, okay, h of 0, whenever k equal to 0, what is the h of 0? H of k value, it is 0. Whenever k equal to 1 and 2, this is the answer. Whenever k equal to 3, h of k becomes 0. So that's why we can write it as this h of 0, 0, and in the expansion, the h of 3 is 0. So only this summation, it can be reduced to summation k equal to 1 to 2, real of, what is the h of k value? The h of k, whenever for k equal to 1 to 2, what is the h of k? E power minus j 6 pi k by 7. Okay, so you see, if you are substituting e power minus j 6 pi k by 7 into this e power j 2 pi k n by 7. Okay, so here you take 2 outside. Okay, then real of this, you combine this 2 e power. So if you are combining the e power, we can write e power, you take a minus j 2 pi k outside. We can write it as 3 minus n divided by 7. Okay, so real of e power j theta. So you know e power minus j theta, it can be expanded as cos theta minus j sin theta. So which one is a real part? Cos theta. So the real part of this e power, it can be written as cos of 2 pi k 3 minus n divided by 7. Okay, then you expand this summation. So if you are expanding, first to put k equal to 1 here. So 2 by 7 cos of 2 pi k is 1. Okay, so 2 pi 3 minus n by 7. Plus if you are substituting instead of k, 2 means, so 2 into 2, 4. So cos of 4 pi 3 minus n divided by 7. So this is said to be the filter coefficient. So in this filter coefficient, we have to substitute the n value, the small n value from 0 to 6. Okay, so 0 to 6, we can get the filter coefficient value. Okay, and already you know, so all this FIR filters are linear phase FIR filter. So that's why it obeys the property, symmetric property. So about this, so 0 to 6 means, so about the 3 as a center, the h of 0 value and the h of 6. The first coefficient and last coefficient, it becomes equal. Similarly, h of 1 and h of 5 will be equal. H of 2 and 4 will be equal. H of 3 is unique. Okay, so the h of 0 is calculated by substituting in this equation. You just substitute n equal to 0. So if you are substituting, we can get the answer is minus 0.07928. Okay, if you are substituting instead of n, if you are substituting 6 also, we can get the same answer. Okay, then similarly for n equal to 1, so you just substitute n equal to 1 here. So if you are substituting n equal to 1, we can get minus 0.321. Okay, so while solving this answer, you should make your calc in radian mode. Okay, so you put your calc in radian mode, then you can solve, since in angle this pi will be available. Similarly, put n equal to 2 in this h of n, we can get the answer is 0.11456. Okay, for n equal to 3, we can get the answer is 0.57. So these are all the filter coefficients. Okay, so the filter coefficient, 7 coefficient we calculated. Okay, then if we want to find the transfer function, okay, transfer function and the realization is asking means, so for this filter coefficient, we have to take the Z transform. Okay, so if you are taking Z transform of the impulse response h of n, we can get the transfer function h of z. Okay, so you know the formula. So the transfer function h of z is nothing but the Z transform of h of n. That is summation n equal to 0 to n minus 1 h of n z power minus n. Okay, so if here if n minus 1 is 6, so if you are expanding, we can get h of 0 plus h of 1 into z power minus 1 plus etc. up to h of 6 z power minus 6. Okay, so then in this You just substitute the h of 0, 1, 2, 3, 4, 5, 6 value here. So we can get, so you see, if you're expanding, we can get like that. So in that already, you know, the h of 0 and the h of 6 coefficient, it will become equal. So if you are combining this first term and last term, we can write it as minus 0.07928 into 1 plus z power minus 6. Similarly, you combine z power minus 1 term and z power minus 5 term since the coefficient is equal. So minus 0.321 into z power minus 1 plus z power minus 5. Similarly, you combine this and this one. We can get this. Similarly, 0.57 into z power minus 3. So this is said to be the transfer function. Okay, so this is the transfer function of our given band pass filter. Okay, this is said to be the design. Okay, so if you want to realize this transfer function in linear phase realization method, means already the linear phase realization of FIR filter, it will be given as a separate video. So in that video, nearly the 4 to 5 problems we solved. Okay, so if you want to realize this transfer function in linear phase realization, means the diagram is like this. Okay, so already you know the method. If you want to learn how to realize this FIR filter in linear phase realization, transversal realization, cascade realization, means, so in my channel, in the name of discrete time signal processing or digital signal processing, the playlist is there. In that playlist, all videos are available. If you want to learn, I will give a link for that playlist in the description box also. Similarly, for this realization problem also, I will give a link in the description box. You can refer it. Okay. So in order to realize this transfer function in linear phase realization, so you see, so here what is the highest order of z? Z power minus 6. So that's why we have to use the 6 delay element. So that 6 delay element, we have to arrange it in top 3 delay element, in bottom 3 delay element. Okay, so here we are giving input here. This is the first delay element. So the output obtained from the first delay element is z power minus 1. This z power minus 1 into x of z, it is given as an input to second delay element. So the output of the second delay element is z power minus 2 into x of z. Then output of third delay is z power minus 3. Output of this fourth delay is z power minus 4. Output of this fifth delay is z power minus 5. Output of the sixth delay is z power minus 6. Okay, so here you see we are combining the input x and z power minus 6. We have to add and we have to multiply with this multiplier. So that's why the x of z, okay, and the z power minus 6 value we are adding. That added value we have to multiply with the constant 0. Okay, here you see the coefficient. Okay, 0.07. So here the coefficients is changed. So 0.079. Okay. Then what is the next thing? Next thing, minus 0.321 into z power minus 1 z power minus 5. So where is the z power minus 1? This one. Okay. This is the z power minus 5. We have to add it, and the added value it will given to 0.321. Okay, 0.321 here. Then the next thing, z power minus 2 and z power minus 4, we have to combine. So this is z power minus 2. This is z power minus 4. We have to combine. We have to multiply it with the constant 0.1146. Okay, 1146. Then finally, the last one, 0.57 into z power minus 3. So here z power minus 3 is available here. So that value we have to multiply with 0.428. Okay. Sorry, 0. Okay, here this diagram is for another problem. So 0.57, you just multiply it with 0.57. So finally, if you are adding all this values, means we can get the output y of z. Okay, so this is the realization, linear phase realization of our given problem. Okay, So if only design find filter coefficient means up to this it is correct. If we want to find the transfer function, and in the question they are mentioning realize the corresponding filter you in proper realization means, so we have to find the h of z and we have to draw this diagram. Okay, so this is the FIR filter design using the frequency sampling method. Okay, so thanks for watching my channel, and please subscribe my channel for more videos, and if, please press the bell notification button, then only you can get notification once I am posting the video. If you want to learn the lecture videos related with the subject digital signal processing, then signals and system, circuit analysis, then electronic circuits to transmission lines and waveguides, antenna and microwave engineering. So for some subject, the MCQ video as well as the lecture videos are available in my channel. So each subject is available in a separate playlist. So if you want to learn that videos means, I will give link for that playlist in the description box. You can refer it. Okay, so thank you. We will meet in the next video with one more problem.